So today we are going to learn how to find and use slopes of lines. So the first thing we're going to do is define what slope is. So slope is the ratio of the change in the y to the change in the x. You probably memorized the formula as y2 minus y1 over x2 minus x1. So slope is always represented by a lowercase letter m. Now, when you're given two ordered pairs, you're just going to put them into this formula, subtract the y's, subtract the x's. When you're given the two ordered pairs, it doesn't matter which one you label again as your ordered pair number 1 and which one is ordered pair number 2. If you're given a graph on a coordinate plane, you can also count the rise and the run to get the slope. Let's see what else. And if you're given an equation, for example, like y equals 3x plus 1, we're going to see that this is in y equals mx plus b form, which is slope-intercept form. And the slope is always located in front of x when it's in this form. So we could also pull the slope out of an equation, and the slope of this line would just be a 3. So again, slope is defined as rise over run. So I used to teach my Algebra 1 class that you have to stand up before you can start running. Whatever way you're going to remember, it's rise over run. Now, I also had one year, one of my students, they were confused because the biggest mistake I see with slope is students put the x coordinate on the top. So this one student told me that this was here in high school, that his middle school teacher told him this story, that you're going to have a picnic, and you're going to have a picnic on the side of a mountain, and a mountain has a slope to it. And you're going to set up a picnic table. So we're going to set up our picnic table. And notice how the legs of my picnic table here are the X's. And on this picnic, you're going to serve some Yum Yum juice. So then we put our glasses that hold our Yum Yum juice here on the top, and then just add in the subtraction sign. So that will sort of maybe help you to remember that Yum Yum juice goes on top of the table and the X's are the legs. Whatever's going to help you remember, you put the X's and subtract them on the top, and then the Y's or the X's on the bottom. So Y's on the top, X's on the bottom. The next slide has the types of slope. When it's a positive slope, your line is going to rise from left to right. When it's a negative slope, the line will fall from left to right. And when it's a zero slope, it'll be a horizontal line. It's always going to be a y equals a number. So let's say if I said that this looks like it's maybe about if I put numbers here, say this is 1, this is 2, this would be the equation of y equals 1. It's always going to be y equals 1. It's not going to have an x in the equation. And this is when it's a horizontal line, it has a slope of 0. When your line is vertical, this is when the slope is undefined. So here it would be x equals a number. So let's say maybe this was 1, and then this was 2 right here, and then 3. This would be the equation x equals 2. Now, when you do the slope formula, what's going to end up happening for the zero slope, after you do the subtraction of the y minus y, x minus x, you're going to get a 0 in the top and then just some number in the bottom. When that occurs and the zero's in the top, this fraction simplifies to 0. But when you get a 0 in the denominator, so some number in the top and a 0 in the bottom of the fraction, you can never divide by 0, so that's why the slope is undefined. So this line, when it's vertical, has no slope to it. You should memorize these two if you haven't memorized them from Algebra 1. A little trick that maybe might help you for the undefined. If you think about what this line looks like, you see how it's going up and down. So if you say it looks like it's going up and down, I could take the letters here and then take the U and the N, and it's spelling undefined. So when your graph is going up and down, the slope is undefined. So you take the U, we're going to take the N out of and then the D. So little tricks maybe to help you remember that when it's vertical, it's undefined, but when it's horizontal, it's 0. Now, the reason why we're covering slope is because our first theorem is the slope of parallel lines, and parallel lines have the same slope. So in a coordinate plane, two distinct non-vertical lines are parallel if and only if they have the same slope. So what you're going to do is I might give you 4 ordered pairs, and I'm going to ask you to calculate the slope of the two together to see if you get the same number from the slope formula. If you do, then you tell me the lines are parallel. So when the slopes are the same, the lines are parallel. Have opposite reciprocal slopes. So what I mean by opposite reciprocals is, for example, 2/3, and its opposite sign would be negative, and reciprocal means flip the fraction upside down. These are examples of opposite reciprocals. So in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1, meaning they're going to be opposite reciprocals. Horizontal lines are always perpendicular to vertical lines. So for example, if you want to visualize this, here's my horizontal line, and if I draw a vertical line, they're always going to be perpendicular. So what this was stating here, that when I multiply a number by its reciprocal or opposite reciprocal, I would get, and I can simplify diagonally here, turn these all into 1s, and then 1 times -1 is -1. Just remember that perpendicular lines have opposite reciprocal slopes. So again, if I give you 2 sets of ordered pairs, you're going to calculate the slope, and then you're going to check to see the answer. If it's the same, you tell me they're parallel. If they're opposite reciprocal slopes, you tell me they're perpendicular. If they're totally 2 different numbers, then you say that they're neither parallel or perpendicular. They're actually going to be intersecting. I could also give it to you as an equation. So for example, if I give you y equals 2/3 x plus 1, and then y equals negative, flip it. Doesn't matter what the y-intercept is. As soon as you see that the two numbers in front of x are opposite signs and reciprocals, this tells me that these two lines are perpendicular. If your equation, or if your slope, let's say you calculated the slope, and let's say you got the slope to be 5. Opposite reciprocal to 5 would be 1/5, and then you flip the sign. So when it's a whole number, remember you can turn a whole number into a fraction by adding a 1, and then when you flip it upside down, then it becomes 1/5. Let's try some sometimes, always, or never questions. So the first one, complete with sometimes, always, or never. The slope of a vertical line is sometimes, always, or never 0. Vertical line, what's its slope? Up and down, so it's undefined, so it will never be 0. Vertical line is always undefined. Everybody with me on that? Next one, slope of a horizontal line is? Beautiful. The slope of a line that rises to the right is always, always positive. I told you the answer. It's always positive. And then the slope of a line that falls to the right is blank negative. Always. So when it's falling to the right, it's negative. When it's rising to the right, it's positive. Let's try practicing calculating the slope given two ordered pairs. So it says find the slope of the line through the 2 points that are named. The hardest part here is just being careful with the signs. So again, remember the formula. Remember, slope is indicated by a lowercase letter m, and it's y2 minus y1 divided by x2 minus x1. Now what I'm going to do is the first order pair that I see here, I'm going to call this whole column my x1, y1, and this whole column, everything underneath here, will be my x2, y2. So now all I have to do is take these order pairs and plug them into the formula. So for the first one, I'm going to be doing, remember the y's go on top, that yum yum juice on the top, so 5 minus 4 over negative 4 minus negative 3. Be very careful with those negative numbers there. So here it becomes 5 minus 4 is 1, but that denominator is going to turn into negative 4 plus 3, which is going to be negative 1. 1 divided by negative 1 equals negative 1. If it will simplify to an integer, simplify it. If it's an improper fraction or a fraction, just leave it in simplest form. Let's try the next one. y2, which is negative 2, minus y1 is negative 3. And then x2 minus x1. Again, be careful. You got to do that key flip change on the top. It really turns into negative 2 plus 3, which is 1. And then negative 1 minus 6 is negative 7. Now you can leave it like that. Just remember that when there's one negative sign after you do the subtraction, you could either pull the negative sign in front of the whole fraction, or if it ends up in the top, you can leave it there as well. So either one would be acceptable here. Next one, same thing. Negative 4 minus negative 4, and then negative 3 minus 8. Top, key flip change it. We end up with a 0 on the top and then a number on the bottom. Remember, when the 0 is on the top of the fraction, this is going to simplify to 0. Notice in my order pairs, the y's of the order pairs are the same number. This should be a clue. When you see that you have the same number in either the x spot or the y spot, it's going to tell you it's either going to be vertical or horizontal. So this one is actually going through the y-axis at negative 4. So this should be a clue that this is going to be a horizontal line at negative 4. Okay, then if we do the last one, 9 minus negative 2 over negative 6 minus negative 6. Key flip change it, and I end up with 9 minus negative 2 is really 9 plus 2, which is 11. And then negative 6 plus 6 gives me a 0. Remember, when the denominator is a 0, this simplifies the undefined. So when you do this on the test, I want to see you simplify these fractions. Don't just leave your answer like this. I want you to tell me that it simplifies to a 0 on this one, and this one, it simplifies the undefined. This is actually going to be a vertical line through negative 6. Again, notice in the order pair, the x's were both the same. So again, that should be a clue to you that when you see either the x is the same or the y is the same, when the x's are the same, it's undefined. When the y's are the same, it equals 0. Now we're going to fill in a chart and fill in the parallel slopes and the perpendicular slopes. So it wants us to complete the table. Now notice up at the top, it's telling me here that R and S are parallel. So this tells me that the numbers that are going to be under the R and the S column are going to be the same because parallel lines have the same slope. However, R and T are perpendicular, So the slope that we'll see under column T is going to be the opposite sign of what's under R and its reciprocal. So for all the S's and the R's, we just have to write the same number. So R and S are parallel, so they have the same slope. T is perpendicular to R. Perpendicular lines have opposite signs, so it's going to be positive, and then I flip that 1/2 upside down. So it really becomes 2/1, and you would just write the answer as +2. Now they're giving us T, so we got to work backwards. Opposite reciprocal to that would be negative, and flip it upside down. So it would turn into 6/1, and then simplify that to -6. For part C, remember the R column is the same as the S, so it gets a 1/5. And then the T column, make it opposite sign and flip it upside down. Line D here, remember R and S are parallel, so same slope. T is perpendicular, so now make it positive and flip it upside down. Now you may look at this variable and you're thinking, oh my goodness, what am I going to do here? But again, if you think of this as A/1, flip it upside down and make it opposite sign. And then that column is the same. Same thing for the last one, flip it upside down and make it opposite sign. And we're done with example 3. It says, if R and S are parallel and R is a horizontal line, what is the slope of S? Well, right away, as soon as you see this, that they're parallel, we know that parallel lines have the same slope. Now we just have to figure out what's the slope of a horizontal line?
0.
And it's 0. So the slope of S will be 0. And again, remember, slope is written as the lowercase letter m. Now, maybe another trick to help you with the horizontal. See how the word horizontal has some O's in it? Vertical doesn't. So if realizing that horizontal has 2 O's in it, if that helps you remember, horizontal is 0. And then vertical is the undefined. Whatever tricks are going to help you. But memorize this. Think of it like a flat line. There's no slope to it. And then vertical, there it's just straight up and down, so it's undefined. Let's try the next one. If K is perpendicular to N and N has a slope of 0, what is the slope of K? So again, here's N. It's got a slope of 0. In order to be perpendicular, K's got to look like this. What is the slope of a line that looks like that? Undefined. Good. So this one, K would be undefined. Always remember that a vertical line and a horizontal line together are always perpendicular. So a 0 slope and an undefined slope together are perpendicular. Now we're going to learn about y equals mx plus b, the slope-intercept form of a line. All right, so the slope-intercept form of a line is y equals mx plus b, where m is the slope, the letter b in the formula is your y-intercept. So it wants me to find the slope and the y-intercept of these 3 equations that are listed here. Now, if you recall from your Algebra 1 days, example A here is in standard form. In order to find the slope, we need to put it into y equals mx plus b form. You can't automatically say that the number in front of x, if it's not in that form, is the slope. So let's fix this one up. Let's get this into y equals mx plus b form. I'm going to take my equation, and I'm going to solve it for y. So I'm going to subtract 2, negative 3y equals negative 2x plus 6. Divide everything by negative 3. And y is equal to, negative divided by a negative makes this slope become positive 2/3. And then positive 6 divided by negative 3 is negative 2. So for question part A here, again, remember the number in front of x when it's in y equals mx plus b form. That's my slope. So my m, or my slope, is 2/3. And then my b is over here at the end, and my y-intercept is negative 2. The next one's already in the correct form. So all I got to do is pull the slope from the front. So this slope of this part B is negative 1/4. And the y-intercept, or my b here, is positive 2. So my b, which represents the y-intercept, is positive 2. Now the last one, if you remember, this one is a horizontal line whenever it's y equals a number. So the slope here is 0. And because it's a horizontal line, it's going through the y-axis at negative 3. So my y-intercept here is negative 3. Now, just to add another one, let's say it was x equals 1. This is a vertical line, so my slope when it's x equals a number is undefined. And then my b here would be none. Because x equals a number, this graph is going to go through positive 1. Right here. Notice it doesn't touch the y-axis. For the one up above, and we're going to be graphing these. Actually, we're going to graph them on the next slide. So I'm going to wait and graph the part C. But just to show you what the graph of the question I just added looks like, that's what the vertical line looks like. All right, on the next slide, I inserted a coordinate plane. So first let me do equation A, and I'm going to take the rearranged equation. So that equation is y equals 2/3x minus 2. Now, one thing you can think about is when it's in this form, y equals mx plus b, maybe think about this b, this y-intercept, this is your beginning point. So on my y-axis, this is where I'm going to put my first point. So I'm going to put it right here on negative 2. And then from there, I'm going to move my slope. Remember, slope is rise over run. So from that beginning point, I'm going to go up 2 spaces into the right 3. So 1, 2, 1, 2, 3, and here's my next point. All I need to do now is, remember, all you need are 2 points for a line. So connect those points, and there's your graph of the line. You can keep repeating the slope, the rise and the run. I could have gone up 2 and over 3. And actually, my line's a little off. Let me see. So up 2, 1, 2, 3. You can keep repeating the rise and the run and get as many points on it as you want to get like a straighter line. Luckily for you guys, when you do this in your Notability, you can hold down your stylus and it'll straighten it up. But when you're doing it on a test, if I ask you to graph anything, you can always use your ID like a ruler. And you can use the edge of the ID like a straight edge. All right, let's try part B here. That equation was already in slope-intercept form. Y equals negative 1/4 plus 2. So again, I'm going to start on my y-intercept, my beginning point, positive 2. Now notice this time my slope is negative. Now, when I would teach this to my Algebra 1 class, I would tell them when they see a negative slope, instead of rising up, we're going to go down, but we still go to the right. So go down 1, and then 1, 2, 3, 4. Technically, you could go up and left. Just make one of the movements negative. Connect your points. And here's the graph of that line. And lastly, part C was that horizontal line, y equals negative 3. So it's got a slope of 0, and it's going through negative 3. So it's this line right here. It's just that horizontal line through negative 3. And that's a quick review of graphing equations once they're in slope-intercept form. So the next one wants us to write an equation of the line passing through the order pair of the point -1, +1. That's parallel to the line with the equation y equals 2x minus 3. What do we know about parallel lines? What do they have in common?
They have the
Same slope. So the slope we're going to be using, I'm going to pull it out of this equation, and I'm using a slope of 2. My order pair, -1, 1. So it's a specific point that it wants me to come up with the equation of the line. So what I'm going to do here is I'm going to use my y equals mx plus b form, and I'm going to be replacing and solving for the y-intercept first. Now, there's also a formula called point slope, but I'm just going to focus on the y equals mx plus b. We're going to plug in the order pair. The order pair we're going to plug in, this is going to go in the x spot. The y is going to go in the y spot of the formula, and then the slope is going to go in the m part of the formula. I'm going to be solving for b. Once I get the b, then I put everything back in. So I'm going to put 1 here, which is the y of the order pair. Then I'm going to put in my slope, which was 2. Then I'm going to put in the x, which is -1. And then I'm solving for the y-intercept, the b. So I'm going to multiply. And I get -2 plus b. And now I need to move the 2 to the other side. And my y-intercept is going to be b. Now I'm going to take the slope and the b and put it back in to this. And now I leave the x and the y alone. So the y stays. Take out the m, put in 2. Take out the b and put 3. So a line that would be parallel to this one going through this specific order pair would be y equals 2x plus 3. Notice if you write them side by side, the one that was given to you had a slope of 2, and the one that you just found also has the same slope. Notice my y-intercepts are different. If my y-intercepts were the same, it would be the exact same line. And it wouldn't be parallel because it would be the same line. Let's try another one. This time we're going to do perpendicular. And again, on this example, it's not in y equals mx plus b. So we need to fix it first. So I'm going to move the 2. Y equals -2x plus 2. Because it wants a line that's perpendicular, I'm going to take this slope and turn it into its opposite reciprocal. So this will become positive 1 over 2. This is the slope I'm going to use. So now again, I'm taking y equals mx plus b. I'm going to put in, let's see, here is this, 2, 3. So this is my x that I'm going to fill in. This is my y. So for the x, it's going to go here. For the slope, it's going to go here. And for my y, it's going to go here. And we're going to solve for b. So I get 3 is equal to 1/2 times 2 plus b. I have to multiply 1/2 times 2, which is just going to give me 1. And then I have to subtract 1. And the b of this new equation, or the y-intercept, is positive 2. Now again, I'm going to rewrite y equals mx plus b again. But this time, I'm only replacing the m and my newly found b. So y equals 1/2 x plus 2. And this line is perpendicular to that one. Yes?
What's the difference between what we just did and what we're doing right now? Because parallel and perpendicular are two different things, but we did the same.
The only difference is once we got this rearranged, this question, we changed the slope that was given to us to its opposite reciprocal. The other one, we used the exact same number. Does that make sense? So the process is the same. The only thing is we changed the slope. Everybody good there? One last example, and this is using the theorem that we learned yesterday about the distance from a point to a line. Now this one's a little bit more involved. It's got a few more steps. So when they're asking you to find the distance from a point to a line, remember it's always the perpendicular segment. So what we need to do first is find the slope of this line. So the slope of this line is -1. But we need a slope that's perpendicular to that one. So we're going to make it opposite reciprocal. Reciprocal of 1 is just 1, but opposite of -1 is +1. So the slope that's perpendicular is going to be +1. Next, we need to find the b. So again, y equals mx plus b. And again, this is the order pair I'm using. 1, 0. This is x, this is y. So I'm going to plug in. 0 equals 1 times 1 plus b. 0 equals 1 plus b. Move the 1. -1 equals b. So now this is the y-intercept. So let's put it back in. Y equals mx plus b. And then here, y equals, the slope we used was 1, so you could just put x. And then the b we just found was -1. Pretty good there? So this is the perpendicular equation to this one. So same thing we just did, okay? But now we got to take it another step. And this is where we're going to bring back our system of equations. We need to find the point of intersection, so I'm going to use the substitution method. So this is where it gets a little bit more applying your critical thinking skills. So y equals -x plus 3 and y equals x minus 1. All I did was take this equation and this one, and I'm writing them side by side. Now, when you learned about system of equations, you either learned the substitution method, or the elimination method, or the graphing method. I'm going to go ahead and do substitution since they're both solved for y. And I'm going to take what this y equals, and I'm going to substitute that and put it, actually it doesn't matter. This one, I'm going to plug in over here. So I'm going to set the two equations equal to each other. And now I need to begin my solving process. I can add x to both sides. This one's gone from here. I'm going to move the 1 to x equals 4. Divide by 2. And the x of my order pair, where the two lines intersect, is x equals 2. Now I need to find the y, so I'm going to plug it in. Doesn't matter which one. I'm just going to plug it into that one. So y equals 2 minus 1, and y equals 1. This is now the point of intersection of the two lines. So it's the order pair 2, 1. And now what I'm going to do is find the distance between this order pair and the one that they gave me at the beginning, the 1, 0. And then this is going to be the distance, and I'm going to use the distance formula now. So now I need to find the distance between these 2 points. And again, it doesn't matter which one you call x1, y1. So let's say this one's x1, y1, x2, y2. So 1 minus 2 squared plus 0 minus 1 squared, all under the radical. Negative 1 squared plus negative 1 squared, 1 plus 1, and the distance is the square root of 2. If you get a question like this on big ideas, you're going to take out your calculator, find the square root of 2, and it actually gives you 1.4142135, rounded to the tenths place, 1.4. So if it says to round to the tenths place, this is what you're going to have to do.